This presentation deals with pollution prevention for the metal plating industry. Just as a quick overview of the sector, it is comprised of over 3,000 job shops in the United States. It accounts for 12.5% of all reported toxic releases in 1992 per the EPA. And it is also a target for pollution prevention because environmental compliance is becoming increasingly difficult with regulations getting tighter. In the pollution prevention hierarchy, substitution is the next best step below elimination. So cyanide-based plating is still widely used today in metal plating. It is used primarily for cadmium, zinc, copper, and other precious metal plating. However, the cost of chemistry in the compliance risk is increasing. With cyanide-free plating baths, there has been a lot of success with zinc cyanide replacement in particular, and there's also been a measured success with copper and nickel as well, but just not as high as zinc. Chromium plating is used in the metal industry for a variety of different applications due to its aesthetic properties and wear and corrosion resistant, but is also highly toxic, and the cost of treatment and disposal has become unfavorable. So there's been a focus on non-chromium aluminum finishing and hard chrome plating, and there's also been a push to replace typical hexavalent chromium baths with trivalent chromium baths. Citric acid is currently being investigated as a substitute for nitric acid. Citric acid is derived from oranges, therefore making it non-toxic, corrosive, and biodegradable for the environment. It's also being looked at as a substitute for other strong acids in the industry. Nitric acid is being looked at for pollution prevention because there are extensive environmental health and safety implications. For indoor quality, nitric acid fumes are toxic. Therefore, most state and local regulations require operations to have single and double stage scrubbers, making it also required to have air permits for the site. For wastewater treatment, spent nitric acid requires sites to obtain NPDES permits to discharge the local POTW and requires other subsequent treatments. Nitric acid also carries extensive disposal costs and reporting requirements. So sites must have a valid EPA ID number, and there are also implications for Tier 2 and Form R reporting requirements. Citric acid has actually yielded better production than nitric acid. It also doesn't require special handling or storage, and it also requires less process time in baths, so there is less chemistry required in changeover with the citric acid. There is little or no treatment required to discharge to the POTW for spent citric acid, so disposal costs are minimalized. There are no toxic fumes, and less chemistry is required overall. Simple process bath maintenance can assist in pollution prevention efforts because it can extend bath life and quality, reduce the amount of chemistry and rinse water required, and it's not expensive to implement. Reducing rinse water continues to be the largest opportunity in pollution prevention for this sector. Reducing rinse water is important because it yields lower operating costs due to decreased utility bills. It reduces wastewater treatment costs, and it decreases the likelihood of expansion needs for the plant because of the lower volume needed to treat. In order to reduce rinse water, sites should investigate rinse water efficiency improvement projects. It should also consider its current tank designs, and it should also investigate flow control techniques. Drag out is defined as material taken out of the process bath as residual and rinsed off in subsequent rinse operations. It increases the amount of chemistry needed in the process baths, and it requires rinse water tank change out more frequently. In order to reduce drag out, there are multiple technologies that sites can consider depending on capital requirements and needs. For example, ion exchange systems, drag out tanks, multiple cascade systems, and evaporators, and the yield is significant for each of these technologies. In conclusion, pollution prevention efforts are worthwhile for any operation because there are many proven technologies available and simple rigor around processes with little capital expenditure is required for pollution prevention.